We have to use L'Hopital's rule to find the limit. First, we have to check what will be when we replace t's by 1. Let me put this in brackets. We have natural log of 1 over square root of 1 to square minus 1. So this is equal, natural log of 1 is 0 over, we have square root of 1 minus 1 is 0, square root of 0 is 0. So we got indeterminate form 0 over 0. When we have 0 over 0 or infinity over infinity, we can use L'Hopital's rule. It means to find the limit as t approaches 1 from right, we have to find the limit as t approaches 1 right of derivative of function which is in numerator over derivative of function which is in denominator. First, I will change this square root to power form because it's easiest to find the derivative. So this is equal limit as t approaches 1 from right, and numerator I just copy, and in denominator we will have t squared minus 1 to power 1/2 because we have square root. So now we can find the derivative of function which is in denominator very easy. So the limit we have to just copy as t approaches 1 from right, and we have derivative of natural log of t is 1 over t. And here we have power function. Let me remind you formula, derivative of power function. When we have du to n with respect to t, this is equal n times u to power n minus 1 times du over dt. In our case, u is equal t squared minus 1. So first we have to take down the power. So we have 1/2 times t squared minus 1 to power 1/2 minus 1 times derivative of function which is inside. Inside we have t squared minus 1. Derivative of t squared is 2t. Derivative of 1 is 0, so we don't have to write. This is equal 2 and 2 we can reduce. So this is equal limit, we have to copy, as t approaches 1 from right of, in numerator we have 1 over t, in denominator we have t squared minus 1 to power negative 1/2 times t. Because we have negative exponent, it means we have to take this expression to numerator. So this is equal limit as t approaches 1 from right, and we have 1 over t, so this t goes down, so we have t times this t will be t squared, and we have t squared minus 1 to power 1/2. Now we have to check what will be when we replace t's by 1. Let me put this in brackets. In numerator we have 1 squared minus 1 to power 1/2, and in denominator we have 1 squared. So this is equal 1 minus 1 is 0, 0 to power 1/2 is still 0, and in denominator we have 1. Now 0 over 1, this is equal 0. So our limit as t approaches 1 from right of this function is equal 0. This is my solution.